Good morning, students. So, in today's class, we will discuss about the topic that is the phenomena of polarization. So, this is the last topic of our chapter, wave optics. So, before going to start with the polarization, so we will know few things about the waves. We will recall. So, waves are classified into two types. That is, one is transverse wave and another one type is longitudinal waves, right? So waves are classified into two. So one is transverse wave and another one is longitudinal wave. So what happens in transverse wave means, in transverse wave the vibrating particles, the oscillating particles which are perpendicular to the direction of the propagation of the wave. For example, the wave is propagating in this direction, then the particles will vibrate perpendicular to that of the direction of the propagation, right? So like this, the particles are vibrating. So this one is the direction of wave. So that is the transverse wave. So example of the transverse wave, as we already studied in the class 11. So here we taken water waves as the example for the transverse wave. Water waves, light waves. So these are all the transverse waves. So what happens in longitudinal waves? So here longitudinal waves, the vibrating particle, the particles which oscillates in the direction of the propagation of the wave. So if this is the direction of the propagation of wave, then the particles in the wave which are vibrating parallel, that is in the direction of the propagation of the wave. So if you observe here, so particles vibrating like this, that is parallel. So here the particles vibrating perpendicular to the direction of propagation of wave, here the particles vibrating parallel to the propagation of the wave. So here in the longitudinal waves, examples we taken, that is sound waves. So already we studied in class 11. So example for transverse wave is water wave, light waves, and example for longitudinal wave is sound waves. So here in transverse wave we get, that is crest and trough, right? So in the transverse wave we get crest and troughs. So in longitudinal waves we get compression and rarefaction. So this one is compression, rarefaction, and this one is compression, right? So this we already studied in class 11. So here what it relates to the polarization means, all the phenomena which we studied earlier, that is reflection, refraction, next interference, and also diffraction. So all these four phenomena which are exhibited by both the waves, that is both by transverse wave and also longitudinal waves, all these four phenomena: reflection, refraction, interference, and diffraction. So these all the four phenomena which are exhibited by these waves, that is both the transverse wave and also longitudinal waves. So we observe interference in sound waves. In the class level we studied the interference in sound waves. In previous classes we discussed about the interference in light. So here in transverse wave we taken light as also example, right? And also we studied the diffraction in light, and also we studied diffraction in sounds. That is, in the previous class we compared the diffraction concept with light and also sound. So sound has more diffraction compared to that of the light. So all these four phenomena we observe in these two waves, that is in transverse wave and also in longitudinal wave. The only one phenomenon which will occur only in transverse wave, that phenomenon is polarization. So polarization, the phenomenon which exhibits only by the transverse wave, right? So this is clear. For this purpose, I will explain the wave difference and also the phenomena which we studied in these two cases, that is in transverse case and also in longitudinal waves. So what is nothing but polarization? So let's start the polarization. So the polarization that takes place only in transverse wave. So light is considered as a electromagnetic wave. As we studied earlier, light is considered as an electromagnetic wave, right? So light is considered as an electromagnetic wave. So in electromagnetic wave we have both electric field, that is denoted by vector E, and also magnetic field, that is denoted by vector B. So light is considered as an electromagnetic wave. So this electromagnetic wave consists of electric field and also magnetic field. So these two waves are propagate perpendicular to the direction of the propagation of the wave. For example, if we consider the axis, right? So this one is Z, and here it is Y axis, and here it is X axis. So these are the three axes, right? So here we have the electric field and magnetic field. So these two are perpendicular to each other. That is, electric field and magnetic field both are perpendicular to each other and also perpendicular to the direction of propagation. So this means that the electric field and magnetic field are perpendicular to each other and also perpendicular to the direction of the propagation. So if we consider the electric field, so this one is the direction of propagation of wave, that is along x axis. This gives the propagation of wave, that is electric field E. The particle vibrates along y and z plane. Then the waveform of the electric field will be written like this. That is, electric field is perpendicular to the propagation direction. Next, if we write for the magnetic field, so that becomes, so this gives the magnetic field which is perpendicular to the direction of propagation, right? So this is propagation. Propagation of the electric field, and in the red lines we are representing the propagation of magnetic fields. So here image will be little clumsy. right? So if we observe, these blue lines are perpendicular to that of the red lines, then these two lines are perpendicular to the direction of the propagation of wave, right? So here you are getting the electric field and also the magnetic field are perpendicular to each other, and these two fields are perpendicular to the propagation, that is direction of the propagation of wave. So here our eye is sensitive to the electric field E, hence we are considering only the electric field vector. So this electric field vector can also called as light vector. So for our study, the electric field E is sensitive to our eyes, hence only we consider the electric field vector. So electric field vector can also called as the light vector. So here we are going to neglecting the magnetic field, that is the electric field only we are going to consider. This electric field is perpendicular to the direction of the propagation of wave, that is light wave. Next, source of light. So next, source of light. If we consider any source of light from this light, so this light consists of a many number of atoms or molecules. So it consists of many number of atoms or molecules. Hence, the electric field of these atoms are vibrating in all the directions. So if we consider this one as the light for the particle for any atom, then here the light source of light consists of number of atoms, hence this source vibrates in all the direction. So if we write, this represents the, so arrow marks represents the particle or atom vibrating in all the directions. So if you observe here, because of the number of atoms are present in the source of light, hence the light particles will vibrate in all the directions. So this type of the light we call as unpolarized light. So this type of the light we call as unpolarized light. So next, what is polarization? So if you understand light, so in light we call light as the electromagnetic wave. So here we have electric field and also magnetic field, which is perpendicular to the direction of the propagation. So our eye is sensitive to the electric field only. Hence, we are considering only the electric field, neglecting the magnetic field. Hence, the electric field we call as electric vector, or we can say this one as light vector. Right? So next, this source of light, any source of the light consists of many number of atoms or molecules, hence the atoms vibrates in all the directions. Because of many number of atoms, the source of light vibrates in all the directions. So thus that type of the light we call as unpolarized light. So next, if we move on to the polarization. So what is polarization? So polarization is a process of transmission of unpolarized light into polarized light. So that phenomenon we call as polarization. So polarization we can observe only in transverse wave, that is only in light waves. We can't observe the polarization in sound waves. So wherever we are going to light, that is electric vector, then that vector we are considering only the electric field, that is only the light vector. So what is polarization? So polarization is a process, that is it is a process of transforming unpolarized light into polarized light. So this phenomenon we call as polarization. So polarization is a process of transforming unpolarized light into polarized light. So what is unpolarized light? So as we discussed, the light source which contains many number of the atoms, hence the atoms vibrate in all the directions, hence that source we call as unpolarized light. That is, the unpolarized light is a light wave which vibrating in all the planes. So what is unpolarized light means? The light wave which vibrate or oscillate in all the plane. That is xy plane, yz plane and xz plane. So in all the planes, then that light we call as unpolarized light. So for that, this is the vibration and this one is the vibration. So this one is the representation of the unpolarized light, or we can, so in the middle we have one dot, for that we have two arrow marks. So here we have dot, here. So this is the representation of the unpolarized light. The light wave which vibrate or oscillate in all the planes, in each and plane. That is plane nothing but, so if we consider the coordinate axis, here it is x, y, z, then plane is x, y plane, y, z plane and x, z plane. So if the vibrating particles will vibrate, that is the atoms will vibrate in all the planes. So plane is nothing but two dimension. Here xy plane and xz plane and zy plane. So the particle vibrate in all the planes, then that we call as unpolarized light. So next one is polarized light. So polarized light is the light wave which vibrate or oscillate in only one plane. Either it may be xy plane, or it may be yz plane, or it may be xz plane. So that one we call as polarized light. So the process of transforming the polarized unpolarized light into polarized light, that phenomenon we call as the polarization. Right? Now you understand this one. The unpolarized light means it vibrating in all the planes. So this light can be transformed into only one plane. That is either xy, either yz, either xz. That is only in one plane. This is important here. That particles will vibrate only in one plane. That we call as polarized light. So if you represent the polarized light, so here this gives the direction of wave propagation. That is, unpolarized light moving in that direction. So here in the middle we don't have any dots. Then these are the particles which vibrate perpendicular to the wave propagation. That is, these are parallel to the plane of, if we written in paper, that is parallel to the plane of paper. Here we have the board, means that is parallel to the plane of board. So if we write in general, it is paper. These vibrations are parallel to the plane of paper. Then this gives the polarized light. So this is the representation for the polarized light. So next is, this is one, and another one is we have only this is also the representation of the polarized light, which is perpendicular to the plane of paper, or perpendicular to the plane of perpendicular to the plane of paper, right? So these two are the representation of the polarized light. So this is the wave which traveling, the light wave, polarized light traveling in one plane, and this is also the polarized light traveling in one plane. So this dot can represent it as like this. So this can written as the waves. So here we have red color in the direction which is in perpendicular to that of x and z plane. That can be simply we can represent it in dots. So here we have two. That is, one is perpendicular to the plane of paper. If consider this one, so perpendicular to the plane of paper, nothing but this one is the perpendicular, like this, right? So parallel means we have to write this one. So these are the polarized light. So representation of the polarized light is as shown here. That is, one is dots and another one is the vibrations which is parallel to the plane of paper. So here we know about the unpolarized light. That is the light which vibrate in all the directions. That is in all the planes. So here we have three planes. Then the unpolarized light is vibrating in all the three planes. Here polarized light means the light which have vibrated in only one plane. Right? So this is about the polarization. Now we have to study the polarization confirms that the light waves are transverse waves. So how we convert this? That is how we can transfer unpolarized light into polarized light means by using polarides. By using polarides, we are transforming the unpolarized light into polarized light. So next, what are polarides? So by using polarized, we are transforming the unpolarized light into polarized light. So polarized lights are a thin sheets. So polarized consists of this one we call as polarized sheet. So the polarized consists of a molecules, that is chainly arranged molecules, that like here. These are the molecules which are arranged in a particular direction. So these are the molecules which are arranged in a particular direction. That is chain of molecules. Right, like this. So polarized consists of long chain molecules which are arranged in a particular direction. So this one we call as polarized. Right here, the molecules are arranged in chain, that is in particular direction. So if you observe here, all they are arranged in row forms. That is along the horizontal, all the molecules are arranged in a chain. So these are the long chains which are arranged in a particular manner. So here all the molecules will arrange like here. So here the molecule chains are arranged in particular vertical manner or vertical pattern. So these are called as polarized. So how it converts the unpolarized light into polarized light? When the electric vector, that is light vector, which pass through these polarized. So this is also a polarized sheet. So if we observe here, the chain of molecules will arrange in the horizontal form, and here if we observe the chain of molecules which are arranged in the vertical form. So otherwise we can simply write this one as in a curved shape like this. So this represents what? Chain of molecules which are arranged in a particular manner, either horizontal or either vertical. So polaroid means it consists of a long chain molecules which arranged in a particular direction. So now what happens? How it converts, how it transforms the unpolarized light into polarized light. So if we observe here, considering this one has the polarized, right? So this is the propagation of the wave direction, right? So here we have unpolarized light. So if we mention here means here we are getting the unpolarized light. Unpolarized light. So the arrangement of the molecules, if we take along horizontal, so this is the, if you observe here, this one is the polarized, and here we have unpolarized light, and the direction of propagation of wave is along the horizontal. So when the unpolarized light, so it consists of the electric vector E, that is light vector associates with the unpolarized light when it falls onto the polarized. So the molecules which are arranged in horizontal, the long chain of molecules are arranged in horizontal pattern. So if you observe here, this one is the horizontal. Considering this one, the molecule are arranged in horizontal. When the unpolarized light which falls onto the polarizer, the molecules are arranged in horizontal. So what happens here means the unpolarized light, that is the electric vector which falls onto the polarized, the electric vector E which are observed by the horizontal molecules, that is the molecules which are present in the polarized, that are observed by the molecules, that is electric vector or light vector which is observed by the long chain molecules. So which light it is going to observe means in the same direction as that of the molecules patterns are arranging. So here the molecules are arranged in horizontal. So the horizontal light waves are observing. So unpolarized light means it is vibrating in all the directions. So the light which are vibrating in horizontal to that of the polarized, then that lights are going to observe. The only light which are coming out from this polarized is, that is the light which is perpendicular to the direction of the polarized, that is the perpendicular to the direction of the molecule. So if the direction of the molecules is horizontal, then we get the light in the vertical, because only the light which are coming from the polarized is the perpendicular lights which are perpendicular to the horizontal molecules. The molecules which are arranged in horizontal, then it observes all the electric light, that is electric vector, then only it passes the light which is parallel, that is which is perpendicular to the chain of molecules. So hence, if you observe here, so here we have the unpolarized light. So here, if you observe only the light which are passing out from the polarized, that light we call as polarized light, right? So here in polarized, the molecules observe the electric field, that is electric vector or light vector, which are in the same direction of that molecules. So only it leaves the molecules which are different from the molecule arrangement. So different means here we have horizontal and vertical unpolarized lights. So the polarized observes only the horizontal lines, that is horizontal, because the molecules are arranged here is horizontal, then it observes only the horizontal molecules, and the light which transmit through the polarizer which are perpendicular to the horizontal, right? So that one we call as path axis. So here the path axis will be perpendicular to that of the molecule arrangement. So that one we call as path axis. So you have to remember this one. If the molecules are arranged horizontally, then the path axis will be vertical. So here if the molecules are arranged in vertical, then the path axis will be along the horizontal. So this gives the path axis, right? So to understand this one, the unpolarized light which falls onto the polarite, the molecules which are arranged in a particular manner, then the molecules will absorb the electric vector, then it leaves the light or it transmits the light only which are parallel, that is which are perpendicular to the arrangement of the molecules. So that light we are transmitting from the polarite, so that light we call as polarized light, that is it vibrating only in one plane. So here the vibrating in two planes or two or more planes. So this is the phenomenon of polarization. So here we have path axis. If the molecules are arranged horizontally, then the path axis will be vertical. If the molecules are arranged vertically, then the path axis will be horizontal. So if we pass the unpolarized light through these molecules, then the electric vector observed vertically light which incidents on this polarite get absorbed and it transmit only the horizontal light, that is the polarized light. So this is the phenomenon of polarization. You have to remember here is the one is path axis, and if the molecules are arranged horizontal, then the polarized light will be perpendicular to that of the molecules, right? So if you observe, this is the molecules which are horizontal, then the path axis will be perpendicular. From this path axis we are getting the light waves, that is perpendicular to that of the molecules. So that one we call as polarized light, right? That is when if you write a statement. So all understand this one. So if you write when unpolarized light falls on a polarized, then we get the polarized linear polarized light which is perpendicular to the arrangements of molecules. right? So when unpolarized light falls onto a polarized, so if we consider this one is the polarized, so here we have unpolarized light. When it falls onto the polarized, so here we are getting the polarized light which is perpendicular to the arrangements of the molecules. So if we are getting perpendicular to the arrangements of molecules, then the molecules are arranged here is in horizontal. So if we getting the dots, then the molecules are arranged in vertical. That is, they are vibrating in this direction. So the emerging polarization light will depend on the path axis. That is path axis. So path axis depends on the arrangements of the molecules. So if the molecules are arranged along horizontal, then the path axis will be vertical. If the molecules are arranged vertical, then the path axis will be along horizontal, right? So this is about the phenomenon of polarization. So in the next class we will discuss how the polarization will tells us that the light is a transverse wave. So we will continue in the next class. Thank you.